All right, so let's work on simplifying rational expressions. But before we simplify rational expressions, let's figure out what rational expressions are. So a rational number is a number that can be expressed as a fraction of two integers, like 3 over 4 would be a rational number. And it comes from the word ratio, like the ratio of 3 to 4. Okay, so a rational expression would just be like 3x over 4. You know, we're part of the overall expression is unknown, right? Three-fourths is a rational expression, right? It's just a very simple rational expression. But now we're going to deal with when there's some variables too and some operations. But it all you know ultimately is something simple like this. Um, it all kind of works the same way, right? So if I have 6/8, really I can reduce that to 3/4, right? Just divide both the numerator and the denominator by 2. So you can think of it as there's this kind of hidden 2 here. 6 is 3 times 2. 8 is 4 times 2. So what you're doing when you reduce it is just dividing this 2 by 2, which is 1. So this just becomes 3/4. So this is what we're going to do, but we're going to do it when there's variables in the rational expression. So it looks weird, but it's not really. It works the same way. So let's start with a pretty simple one, 10x over 2. Um, so let's just rewrite this the as the product of its factors, meaning um, how can I split up this 10? I could write it actually as 2 times 5 times x. So 10x I can rewrite as 2 times 5 times x. And 2, you know, that's as far as it goes. I could rewrite it as 1 times 2, but that's not going to get me anything, so I won't do it. So now, so they have the numerator and the denominator of the expression have a factor of 2 in common. So I can cross out the 2, meaning 2 divided by 2 is 1, and 1 times something is just that something, so we can just say that's gone and just call it the something. So 10x over 2 can be reduced to simply 5x. All right, what about this guy? I should say equals 2 times x over 2 times 3 times x, right? 6 is 2 times 3, so they have this 2 in common. They also have this x in common. So all I'm left with is, now here's a good reason to write that 1. We could write this as 1 times 2 times x. So then it becomes clear that what we have left is 1/3. I've got a 1 left up here after these guys are gone. I've got a 3 left here when these guys are gone. So let's keep going. Let's kind of build on that principle. 2x squared we could rewrite as 2 times x times x. 6x cubed we could write as 2 times 3 times x times x times x. The 2's cancel out. 2 pairs of x's cancel out. So all that I have left in the numerator is a 1. All that I have left in the bottom is a 3 times the x. So this is 1 over 3x. Alright, going okay so far? Okay, now let's look at something that's a little bit more complicated, although not really. What are the factors of the numerator here? Well, that is factored as far as it goes. I mean, you could look at this as 1 times x plus 3. But when you have an expression here where something's being added or subtracted, you have to treat it as a whole unit, as a whole object unto itself. It is a factor. So we want to split the numerator and denominator into its factors. So this is already factored. Now the bottom is just 2 times x plus 3. So what they share in common is an x plus 3. So all I've got left is 1, 1 over 2. Okay, so keep that in mind when we go to this one. Now, don't think that you can, think this is not 2 times x times 6 and x times, you can't, what am I saying? This 3 and this 6 can't cancel out anyway. That doesn't reduce to 1/2, right? This is part of something that's being added or subtracted, so you have to treat it as a whole unit. Well, x plus 3 is not the same as 2x plus 6. These are not the same factor like they were here, so you might think that you can't reduce further. But notice this. I could factor out a 2 from the bottom. What times x is 2x? 2. Or I should say, what times 2 is 2x? X. So, right, if I were to factor this, 2 times x is 2x. 2 times 3 is 6. In other words, if I were to distribute this, I would get 2x plus 6, right? So I could rewrite that as the factor of 2 and x plus 3. Then I've got x plus 3 in the top, right? So now these factors cancel out, so all that's left is 1/2. So look for ways in which you can pull out factors, even if it's not obvious at first. I'm just compulsively circling my answers here. Alright, now let's look at this one. X plus 3 over 2y plus 6. It looks very similar to this one, so you might think, I could, right, I mean, you could factor out that 2. 2 times y plus 3 is equivalent to 2y plus 6 over x plus 3. These cannot cancel out, though. X and y mean two different things. Who knows what they stand for? Maybe x is 10,000, maybe y is 3. So these are not common factors. We don't, you can only do that when it's the same variable, right? So this is as simple as it gets. All right, last one. 3x plus 2 over 6x plus 10. Now, can we factor the top in any way? Like 3 times x? Not really. We could call it 3 times x plus 2/3, but that's not going to help us. What about factoring the bottom? So let's just leave the top the way it is. The bottom, what we'd like to do is ideally if we could factor it so it's something times 3x plus 2, then we'll be able to cross it out, right? So what can we do here? What about a 2? 2 times what is 6x? 2 times 3x is 6x. 2 times what is 10? 2 times 5 is 10. Alright? Well, we got pretty close here. But 3x plus 2 and 3x plus 5 are not the same. So we cannot cancel these out. Right? It's pretty close. We tried. But they have to be exactly the same factor in order for them to cancel out. 3x plus 2 divided by 3x plus 5 is not 1. Alright? So that's as good as we can do. Alright, that's it. So simplifying rational expressions. Really, if you just break up each part of the expression into factors, the top and the bottom, and then see what you can cancel out, if anything, that's all there is to it.